So yeah, diving straight in. My name's Andrew Triantaphyllou. As Patrick mentioned, pronounced my name perfectly. Thanks for that. I'm the technology manager for the Design for AM research team at the National Centre for Additive Manufacturing. And I want to give a short presentation on what we think the opportunities are with this research network. And I want to say really just before I start that it's really exciting to be at the launch of this network. And my kind of perspective on it is that I started working in additive manufacturing 8 years ago at the National Centre for AM as a research engineer. And after a couple of years, it was like obvious that no one was actually looking at design for AM. So that's when I started sort of looking into this area. And as Olaf was describing, at the time, people were just coming in to the MTC to get stuff made. There was no interest in design. They just bring something they machined. So can you print me one of these, and then turn around and walk home when they found out how much it was going to cost. And to look back there and now to where we are today, where there's a lot of interest in design for AM, and customers coming into the company now specifically come to us for design for AM training, because there's an awareness growing now that you actually, if you want something good to come out of well, anything really, you have to design for that good outcome, and people are realizing how much that applies to additive. So it's really good now. It's really gratifying to have worked for 6 years on this subject and to see that industry are really getting the message. And then for the EPSRC to come along and fund this network, I mean, specifically on this field, it's just like the icing on the cake for me. It's brilliant. So thanks for the EPSRC for the funding, and also thank you to Patrick for making this happen. So what I want to do is just give you, as I said, a brief talk. I'm here on behalf of the National Centre for Additive Manufacturing, and we're a partner in this research network. Our role here as a partner is to represent the needs of industry, and our tacit contribution to the network is going to be a report that the network has had on the impact on industry at the end of the funded period of the network. So that's great. And what I thought would be good to do then in this presentation is just sort of describe what we do at the NCAM in DfAM team, and so you get to know us, who we are, and how we can contribute. And I think there's a lot of synergy in what we already do and what the network is trying to achieve, and hopefully that will come through with these slides, and we can work together during the network as well as us producing this report at the end. So first of all, well, who are we? The DfAM team, we're the little circle in the middle of this diagram. The DfAM team then are part of the National Centre for Additive Manufacturing, and the National Centre for Additive Manufacturing is part of the Manufacturing Centre, and the Manufacturing Technology Centre is part of the High Value Manufacturing Catapult. So that's how it all fits together. And if I kind of go back in reverse order, the High Value Manufacturing Catapult is was founded by government. The idea is that we help industry adopt new technologies. So that applies to all of the centres. We focus on manufacturing, but for high value applications. And we focus on basically removing risk and barriers to adoption of technology. So all of the centres have their own research themes. The MTC has several. One of them is additive manufacturing, and that research theme then has several teams. There's design for AM, but there's also AM process. There's post-processing, powder material management, inspection, metrology kind of aspects. All sorts of research teams going on, and we are one of them. And we sort of tend to work in the TRL kind of sense, because we're a manufacturing focus. So we talk about technology readiness levels, which I'm sure you're familiar with as concepts, where your TRL1 is an idea in someone's mind, and TRL9 is injection molding or some other process that's just regularly used. And we tend to focus on the gap in the middle, which is where the barrier to adoption for industry is. And that's how we want to help with the network. Just a quick slide on the focus area of the MTC. These are the kind of industries or sectors we primarily engage with. So we have these sector leads at the MTC, and they will go out looking for what the issues are in these sectors. So I'm aware that the research network's got a much broader remit than this. So, consumer goods, for example. We'd like to be involved in wider topics than this. So the network is an opportunity for us to do that. But this is just to let you know that this is where our key contacts with industry currently are. So what I've got is a couple of slides which just describe what we do in the DfAM team, and the ways that I think we have overlap with what the research network wants to achieve. So I mentioned the TRL levels. We tend to kind of have that as our metric. So these examples of the things we do are from the high end of the TRL scale, kind of looking to the right, where we look to industry, who are effectively our customers. And these are some examples of the sort of activity we do. We do design, obviously. So demonstrators is probably the most sort of common thing we do. Demonstrators of people trying to evaluate the technology. We'll design something and they'll go and rig test it and decide whether to use it. So the picture on the top left is an aileron hinge. So it's just basically a bracket but holds an aileron. So it's quite an important bracket. It's made in titanium in EBM. It's pictured there with the support wafer still attached. That was a European collaborative research program. And the idea was there that we would take a flight to critical part and go through the lightweighting journey to save on fuel and emissions and show the workflow. So we had to go through the design and doing the sort of qualification test program, certifying, getting all our data traceability, design authority stuff sorted out, and show the whole workflow. The picture next to that on the right is a polymer. So this is an all-10 part FDM. This is a sandwich panel insert for composites. We did this project with the National Composite Centre, who are also part of our research network. And this is just showing, can you use polymers in fairly high temperature applications to move away from this dependence on metal for everything. Bottom left, that's an image from Entopology. It was mentioned before by Olaf. So Entopology, as you'll probably know, implicit modeling. It's software that we are trying to evolve. So we're looking at new design tools coming out that will help you do, or help industry rather do better design and really get value out of what they're designing. So looking at emerging software is always something we do on behalf of industry. To the right of that is training. So as I said, there's a lot of interest in training now. We've got multiple DfAM training courses. One of them is delivered around the world, literally, by the people in our team. And so we've got a very strong link to the training, which is one of the things that's mentioned in the goals of the research network, upskilling the workforce, changing people's mindset, all of that kind of thing, which is great. Another thing, production DfAM workflow. So industry, they really want to just adopt AM and put it alongside other processes they already have. They don't want to set up a whole new way of life for additive. And we need to sort of help them understand how, when you're designing for additive, what's going to change to what you normally do, and how much of what you do now you can keep, and use what software you can still use, what new data sets will you need to handle, and that kind of thing. So this kind of study for industry helps in their adoption. And to the right of that, the ASTM Center of Excellence. The Center of Excellence, ASTM, the American Standards Organization, the Center of Excellence they set up a couple of years ago. It's actually specifically looking at standards for additive manufacturing, although it doesn't say that on the logo. So it's an AM-only Center of Excellence. We're a member of that center. We're the first overseas, well, non-American organization to be part of this. So we're really heavily into standards. We understand the importance of them for industry. They're very boring to read, but they're very useful tools. And Farhan, one of the guys in the team, has just finished the design for post-processing for metal powdered bed as part of this Center of Excellence. So we're fully into that. And the top middle, AM technical data pack. So it gets a bit dry here, but this is like what we need in industry. So industry needs to understand how the engineering function needs to communicate with their manufacturing function, and what information needs to be given so that a designer can design something and kind of be as sure as possible that they've specified and defined all of the variables, such as some of the ones Olaf mentioned, that will affect the outcome of their design intent. So how do we control the variability in the manufacturing process as much as possible? So this is done through the technical data pack that you give to manufacturing. And these things haven't been defined. AM drawings, we're defining the sorts of AM drawings you need, what the information needs to contain. And top right, the leg prosthetic. This is just a nod to the the mission of the Manufacturing Technology Centre generally. So, the mission that the MTC has is to impact society. That's our mission statement: impact society in the right way. So the company wants all of our efforts to be for a positive outcome for society. And so, if we kind of roll back down to DfAM, the application for us then, or the mission for us, is to maximize the impact of additive manufacturing on society through good design, because we all know, without design, you're not going to get the outcome you need. So this leg prosthetic was an MTC funded project, just to show industry and the community how AM can help. So these are all the things we do. Kind of looking to the right, we're a company, so we need funding. Funding comes from our commercial customers, who are the high TRL level users. And I think there's a lot there that we can sort of help with the network with. The other side of the TRL scale is to the left. So this is about you guys. You're the innovators and the thought leaders in this space. So we look to you. You're the people coming up with the new ideas, the new tools, the new methods, the new applications. And we are in the team really hot on finding out what's going on to the left and bringing these new ideas and showing them to the people on the right, the industrial partners. So, for example, Limit State is a software company spun out of Sheffield University, as you'll probably know. They've got this novel way of optimizing structure, and the aileron hinge I showed you on the previous slide. We didn't have a remit as to how to lightweight this bracket, but we chose to use Limit State because Limit State was suited to the kind of design, and it's a novel design method. And by using Limit State through this European funded project, we're kind of exposing Limit State to industry and saying, look, you don't have to do continuum optimization for everything. There are other ways. So we like to support emerging tools and methods coming from the academic side. And the same would apply to Gen3D, the spin out from Bath. So we're using their software, which is good for doing the manifold that Olaf mentioned. We're using them in another project called Drama at the MTC. We're also part of the CDT at the University of Birmingham on topological design. So we really like to engage with the academic side of this space. We're involved in a couple of researcher in residence programs. Unfortunately, I wasn't given the clearance to show the images for this presentation, but one at Exeter and one at Bath. So another engagement there. A bit lower to the right, the bone fixation concept. So this is a PhD we're sponsoring at University of Birmingham as well. So we do sponsor 2 or 3 PhDs a year. And I think the network will help us target that sponsorship, because we'll be able to help develop ideas coming out from what you suggest as part of your roadmap. And up where the little box says field-driven manufacturing, there's nothing to show there because that's a bit blue sky. This is something we're just starting to work with Patrick on. So if you take entopology, which is like this field-driven way of defining geometry, which is obviously going to open new doors for the way we design products. Field-driven manufacturing takes that idea and says, well, what if you can not only define the geometry and the shape of your object by field, but can you go into the manufacturing area and say, look, here's my inspection instructions for this object, and rather than using technical drawings or annotated models, could you just use a field that's also come out of the field that drove the design, and then that field can then adapt to the change in design and update the manufacturing instructions. So this idea of simplifying and smoothing the digital manufacturing workflow is something we're exploring as well. And top right then, auxetics. So we do work on basically upskilling ourselves on ideas that really aren't really prevalent in industry and we think should be. So auxetics, for example, we're doing a project now. We're going to publish a paper with colleagues from Leeds University on how you design auxetic structures, because it's not something people know and maybe they can get new application. So these are the kind of things that that we do in our team. That these looking to the right for industry, looking to the left for academia. And I think it should be fairly obvious that there's a lot of overlap here between what we do and what the research network is trying to achieve. So I've just got a couple of slides I want to show you. I'm basically going to ask for your help, and I think the research network is set up for this sort of thing. So the first one is about functionally graded materials. So you all know, and I know, that functionally graded materials are amazing. The kind of the mind boggles in the way that they could modify the products that we see today and create a whole new class of products where the material properties throughout space are tailored to what the designer wants them to be, rather than just being a homogeneous structure. So this idea is just fantastic. And the hardware exists because you can buy a printer, a polymer, or let's say the PolyJet printer, or you can use blown powder DD to make graded material structures in polymer and metal. Now, it's there. We can do it. So there's no technological barrier to this application. So, why aren't we seeing any functionally graded material products? There aren't any. And if you think about it, if you're trying to design a functionally graded material product, well, first of all, how am I going to do it? Because I can't use CAD. CAD just talks about the outside. It doesn't talk about the way the material is changing in the volume of the object. So I'm already stuck. And then if I've got my design, how am I going to simulate it? How am I going to predict how it's going to perform as an object and do what I want to in the environment I put it in? And how am I going to specify the material? How do the various materials in this object blend into each other, and how does that affect the performance? And if you sort of take it one step further, how am I going to test it? What does a tensile test coupon look like for a graded material? I've got no idea. And then let's get to manufacture. How are you going to verify what you've made? You've got some object that's got like varying hardness all the way along it. How are you going to verify that you've made it correctly? You're going to make little indents every 2 millimeters along the object. So there's a whole raft of unknowns. And so we've got the machines, we've got the ideas, and we've got these unknowns. And industry won't adopt with these barriers in the way. So this is something I think that we should be able to do more with. What we did about 3 years ago now, we did a little project. We funded it internally because it's like we've got to let industry know about these graded materials. So we got some software, Monolith, that now owned by Autodesk, and we did some trials on the Stratasys machine. We made some trial parts just to demonstrate, in this case, graded hardness. And we came up with a design workflow and explained what software you'd need and what the data set were, what would be that you'd be handling. And the response from industry was zero. There was just no interest. So I think what we need is, if you think about what the key research themes that Patrick outlined previously are, they pretty much cover all of the gaps in this particular example. The way you do designing, the geometry, the data, testing, all of the bits that are missing are within the remit of this network. So my point here is that if we can give you ideas that we think will help industry, and say, look, let's cross the gap for them and fill in the blanks, then that will be a fantastic outcome for the network. It's not our remit now as the partner to tell you what to explore, but if we can give you some ideas such as graded materials and say, look, this is what's missing, and then you can decide whether to put research effort into that. So that's helping with the technology push, and then we can make nice products, make them graded products, show industry, and they'll start thinking about how to actually use them. And the other example where I think help, because it's quite hard for me to do, is this idea of industrial pull. So it's one thing telling them, yeah, graded materials, great, but really we've got to think about what industry are asking for as well. And these two roadmaps, you're not supposed to be able to read them. They're very small. It's just the idea of a few bars going off into the distance, just a generic roadmap. We've got in our team our own technology roadmaps. We look at the sorts of things we think industry are going to need to know about. For example, how do you design an orthostatic structure? Or how can you predict control material properties in this variable process? How would you design for fatigue? All of these are on our roadmap, and we are doing projects to answer those questions. Our customers give us other roadmaps. So the sector leads at the MTC go and talk to industry, and they formulate these sector roadmaps. And the roadmaps are kind of a different language. So let's say if it's an automotive sector, the automotive sector is saying, we need flexible manufacturing. So we need a rapidly reconfigurable production line. Fine, would you like a compliant mechanism? There's no handshake. We need help with the handshake. So it's like, how do you interpret the need for a rapidly reconfigurable production line with the technology we have and the applications we have? And I think if we can sort of chuck a few roadmaps your way and say, look, here we are, this is what industry is asking for, you can then again look at them and say, okay, is there anything that we can make as an application that will then fill in that gap? So that again is, I think, another opportunity we can work together on. And my last slide then is just a summary of that. Won't read through it all. I think basically it's what I said. The only one I would point out here that I didn't emphasize in the presentation is the international collaboration. So we do a lot of Horizon 2020 and other kind of CR&D projects with Europe in the National Centre, which means that we've got a lot of contacts in Europe for design and other related issues. So we're happy to contact them and bring them into this network as well, because I think international collaboration is also one of the network's goals. And that's my presentation. Thank you very much.